Hello, my name is Sarah Brown. I am a sophomore pre-nursing student and I am currently in Chem 102 right now. And kind of the reason I really wanted to be a ULA is because chemistry is notoriously a difficult subject. There's multiple moving parts throughout the problem. But the great thing about ULAs is that they were able to take the time and break down a problem into manageable chunks. And so that made studying for exams and actually taking the exams much easier. That is also one of the main reasons I want to be a ULA and how I will contribute to helping students make effective study strategies is that I found it most helpful to really break things down into small manageable parts and kind of combine those parts together to the end to make a meaningful product. And I will kind of be showcasing that through this problem. So we're just going to start. Exactly 10 milliliters of water at 25 degrees Celsius is added to a hot iron skillet of mass 1.2 kilograms. All water is converted to steam at 100 degrees Celsius. What is the temperature change of the skillet? So at the very beginning, we can recognize that this is a thermochemistry problem and it is dealing with heat. And so we are going to be dealing with Q here. And what we see is that the water is heating up. So that means what? That means our Q value for the water is going to be positive. And our iron is giving that heat to the water. So we know the Q value of the skillet is going to be negative. So this is just kind of a way to not idiot proof it, but just kind of check, if you're getting a negative value for Q when you know it should be positive, that means we have to stop and rework the problem. So first thing I want to do here is recognize what equation we need, and for the water we need two. We have the Q equals mCS delta T, which is our mass of water, the specific heat of water, and the change. We know that the density of water at 25 degrees Celsius is 1 gram per milliliter, and we have 10 milliliters, so we know there is 10 grams of water. The specific heat is given at 4.184 joules per grams time Kelvin, and our delta T, we are starting at 25 and ending at 100. So our delta T is going to be 75 degrees Kelvin or Celsius. And the reason we can use either is because Kelvin and Celsius both go up at the same rate. 1 degree Kelvin increase is the same as a 1 degree Celsius increase. So if we plug in these values, we get that Q of the water before it turns into steam is 3,138 joules. But, and also important here, it is converted to steam. So we have to also take into account the energy given from that. And we know that delta H vap of water is 40.7 kilojoules per mole, or 40,700 joules per mole of water. And we know the molar mass of water is 18.015 grams, and we have 10 grams of water here. So our moles of water is around 0.555. So if we combine these two values, we get 22,592.28 joules. And we can actually add these two together to get the total amount of energy absorbed from that water. And that number is 25,730.28 joules. Now, this is positive. This checks out with our first check here. We know that the skillet is negative, and we also know that these are related because the iron is directly heating that water. So we can assume that the Q of water is equal to the negative Q value of the skillet. So that means that Q skillet is going to be negative 25,730.28 joules. Great. Another thing we need to do is we notice that our specific heat of iron is given in moles, and we know kilograms. So first we have to convert kilograms to grams, which is 1,200 grams. Then you have to divide that by your molar mass to get your iron, and it is around 21.480 moles. So now we have all of our values except for delta T, and we know we are going to be using Q equals mC delta T. So we isolate delta T by saying Q divided by mCS is equal to the change in temperature. We know our moles, we know our CS, and we know our Q, so we plug in our values. And we have to make sure all of our units cancel out. these joules will cancel out, these moles will cancel out, and all we're left with is Kelvin. It is also negative, which makes sense again because the iron is losing heat. And so we get an answer of negative 47.5 degrees Celsius, or Kelvin, because we're talking about change. And this makes sense because we know that the iron is losing heat. So that's how I would go about solving this problem. Thank you so much for your consideration.